Welcome to our review on electromagnetic waves and matter. Now, the first thing that we really need to understand is how to draw a ray diagram. Hopefully this is something you did do all the way back in Key Stage 3, so that what you've done in your GCSE is just a reminder. But just in case, ray diagrams are used to show those key behaviours of our actual rays, so reflection and refraction. So a few key points to remember when we come to draw our ray diagram. First of all, use a ruler. Do not try and draw this freehand. It will not go well for you. Secondly, use a pencil. If you make a mistake, you can rub it out. You only get the one version of the diagram on the exam paper, so don't do it in pen. And then if you make a mistake, you're kind of stuffed. So always use a pencil and a ruler. When we're actually drawing the rays, then that is a straight line. When we actually come to draw our diagrams, obviously it depends on what we're drawing as to how it's going to be set out. So if we consider reflection first of all, the top diagram there, then what we can see is that we've got our angle of incidence at the top. Now that's the angle between our normal line and our incident ray, the one that comes in. So your normal line is at 90 degrees to the actual mirror. So what we do is we have our angle of incidence measured, and then on the other side we measure the exact same angle, and then we know our angle of reflection, because hopefully you remember that the angle of incidence is the same as the angle of reflection. Once you've done that, just put the arrows on to show the direction. Go careful when you're doing this though to make sure that number one, the rays meet and they meet on the mirror. Don't cross them over or have them meeting a little bit in front or just not meeting at all. So just go careful and take a little bit of care over drawing that diagram. The bottom one there is showing us refraction, which is the bending of our light. And what we have, still our normal line at 90 degrees to our surface. Our angle of incidence, again, between our incident ray and our normal line. But as we're going from air into our glass block, then what happens there is it's going to bend towards the normal. So the angle of refraction is obviously going to be lower than the angle of incidence in that case. But again, add the arrows to show the direction it's moving in.